Welcome back, everybody. This should be video number 2, going over how to draw our miniature train parts. And today we're going to focus on the train stack, which the final product kind of looks something like this. But I'm going to kind of show you how to do this from the beginning. So whenever you start a new part, you always click on this plus button here. Now, when you're looking at the prints for a lot of these parts, sometimes you can get an idea of how the designer and or engineer wants this to be drawn on Fusion or in other CAD software by looking at this print. So whenever you see these dashed lines right here, these are called section lines. They kind of show the interior material of the part. So you can kind of see how these section lines represent whatever material this train stack is made of. Whenever you see section lines, I want you to think in your head about doing something called revolving. It's a different type of extrusion on Fusion, but I'm going to kind of show you how to do this today. So essentially what we're going to be doing is we're going to be drawing half of this shape. We're going to be outlining this part here as best we can, and then instead of extruding this as a kind of a just three-dimensional figure, we're going to be revolving this in a circle around a center axis. So that might be confusing right now, but once we start drawing, I hope it'll make sense. So again, we're just drawing half of this. The other thing to keep note of is when I'm drawing this, I'm going to reference diameter and radius. So remember, the diameter is this symbol here, the circle with the line going through. That represents the distance from one side to the other side of a circle cutting through the middle. That's the diameter. The radius is half of that. Because we're going to be revolving this, when we draw these, we're only going to be drawing half of the actual diameter, which in other terms is called the radius. So for example, this bottom piece right here is a 0.5 circle. Well, since we're revolving it, we're only going to draw 0.25. Okay? All right, here we go. So let me get my mouse on here. The way that I like to set this thing up is I like to draw some of our known dimensions first. We're going to do this all in one sketch, and I like to kind of use a whole bunch of different lines to lay out this part. So the first thing I'm going to do is I'm going to draw the height of this object right from here. Okay, so the height of the entire thing is 1.75 inches, which we can see on the print. I'm going to zoom in, try and make this thing a little bit full screen for us so you guys can see it. Okay, then on the bottom, I'm going to come over. I know the bottom diameter is 0.5, so I'm going to draw this line as 0.25. Okay, I'm going to come up 0.25, because that's what the print tells me. And sometimes I like to pull these dimension lines away so I don't get them, confused here. So that's 0.25, that comes up 0.25. And now I'm going to draw some other lines over here, horizontal lines, to kind of mark all of these different diameters happening up top. Okay? So here we go. Let's draw a line here. So we said the whole height of this thing is 1.75. That top circle, it doesn't say how big this exterior extrusion here, this circle is, but it tells us the size of the interior one. So let's see, it says that this is a counterbore, and this circle's 0.875, and this small circle's 0.375. So what I'm going to do here is I'm going to come down to my screen here, and I'm just going to draw a line that goes all the way up. I don't care how tall it is. And I'm going to dimension this to 0.375 is the diameter. I'm going to do half of that. 0.375 divided by 2. Okay. And again, we're going to have a lot of lines that are overlapping. It's going to look a little bit confusing, but I think by the end you'll understand what we're doing. I'm now going to draw a top line. I don't know how big the top diameter is, so I'm just going to draw a large one. It just looks like that. I know this is probably really confusing right now, but it's okay. So then if you look on the print, we have this circle right here that comes out. Now they actually gave us the diameter for that. They say that this ring is 1.25. and it looks like it's 1.5 from the bottom. So let's draw a line that is 1.25 in diameter. So we're doing radius divided by 2. And now let's dimension this line from the bottom. And it looks like it's 1.5 tall. Like that. Okay, so we're good so far. Now, what we can do is we can actually connect this line here, this outer ring line, right down to this line that we drew. We don't even need to know what the angle is of this one. Okay, so that's connected. That looks good. All the lines are black, which means that they're properly dimensioned and constrained. Now up top here, they give us this weird dimension. It's an angle or angular dimension of 15 degrees. So here's what they mean by that. So it looks like there's a line that connects to the top here at an angle of 15, but what does that actually mean? Well, let's figure this out. Let's just draw any angle and any length right here. It doesn't matter. Let's draw that for now. The line's blue, so we have to add a dimension. So what I want to do is I want the angle between here and a vertical line to be 15 degrees. Now the problem is I don't have a vertical line. I can draw one as reference and then dimension it, but I think it'll be easier dimensioning from here to here. Because if we know that from here to this vertical line is 90 degrees, our line needs to be dimensioned at 15 degrees. Well, if we do the opposite angle over here, 90 minus 15 is going to be 75. To do this, hit D for diameter, click on your line, click on another line, click again, 75. So that means that this angle is 15, because 75 and 15 equals 90. Now, I'm going to trim this up just because I like to. I'm going to trim this line with the scissors. I'm going to trim this line as well. So now you can start to see how this thing is laid out. So we have this hole right here. We want to make sure that this 0.25 line comes all the way down here. Okay. Now all we need to do is draw this larger counterbore hole. So it looks like, if we look at our dimensions, it's a 0.875 hole that goes down 0.375. So let's try and do that. So let's draw a line that comes down, D for dimension. So this should come down 0.375. Okay. And then L for line. From here to here, we need to dimension. This should be half the diameter. Again, the diameter is 0.875 divided by 2, the radius. Okay, now you can start to see what our counterbore looks like. So I know it's a little bit confusing with all of these lines going on, but it's okay. We're going to keep them. I could trim them, but I want to kind of finish this part first. So the last thing that we have here is we have this hole that we drew. We want to make sure that this hole depth looks like this hole here is 1.5 from the top. So let's draw a line. Let me get my mouse back here. Okay, I'm going to draw a line anywhere, and I'm going to dimension it to be 1.5 from the top. And it looks like it was already there, so I can undo that. This line that we drew that was 0.25 from the bottom will work for us, so I can delete this one. The reason that this works is because this bottom piece is at 0.25 and this whole shape is 1.75 tall, we can assume that this hole is 1.5 deep. Okay, so now let's take a look at this. I could trim this line. Let's just trim it to make me feel better. We'll trim that one up. And now let's revolve. So we're going to hit Finish Sketch. I know there's a bunch of overlapping lines. That should be okay. Let's click on Revolve, and now let's pick the shape that we want to revolve. So we want to revolve everything in the section with those diagonal lines, those section lines. That's what we want to revolve. So let's do this profile, this profile here, and this profile and this profile. Yes, I think that's correct. That looks pretty good. And then for axes, we're going to choose the center axes to revolve around. So our shape looks like that. And we're going to hit OK. And right there is our finished train stack. Feel free to go back in the video, take a look at these dimensions again. It says optional chamfer, so I'm looking at the print. Optional chamfer at the bottom edge. If you want to put a little angle on the bottom, a chamfer is what we call that. It's this tool, chamfer. You don't have to do this. If you click on this edge here and you type 0.01, it'll put like this little bevel on there for us. We call that a chamfer. Yeah. All right. Hopefully you enjoyed and you were able to get this done. We will see you at the next video.